it's a pleasure to introduce to you Bryan Swistock during today's presentation, and he is in the Center County area of Pennsylvania, which is right dead set in the middle of Pennsylvania, near the Penn State University. So Bryan, thank you for joining us today. Thank you for your willingness to share, and I'm going to stop sharing my screen and turn it over to you.
Okay, thanks, John. Can you just confirm that my sound is good here?
It is.
Okay.
Yeah,
thanks again, John. I thought what I would do today is basically talk a little bit about basic information about the normal kinds of water supplies that we're testing, which are typically private water systems, rural drinking water systems, and then we'll talk about some basic water testing information, but spend most of our time really about interpretation of water test reports. We'll go over some examples, look at the different components of water test reports, and how they differ. You know, there's really no standard way that water testing labs often report their information. So sometimes you just have to look for the different pieces and the way that they're presented by different labs. And so I'll show you some examples of that as we go along here. So as far as private water systems, and again, as I said, typically we're testing related to gas drilling. We're in rural areas, so we're mostly dealing with what we would consider a private water supply, which is a well, a spring, a cistern that serves an individual home. You can certainly have cases where public water supplies may be tested if they're in the vicinity of drilling, but the vast majority of the testing is around these private water systems. And really, when we're testing water, regardless of why we're testing it, we're always trying to just document the conditions. So that might be that the homeowner just wants to document their water quality to determine if they need water treatment equipment. Or in the case of gas drilling, it might be that we're trying to document the pre-drilling conditions or the post-drilling conditions, and that might be from the perspective of the energy company or from the homeowner perspective. But regardless, any water testing that's done, we're just trying to document what those conditions are at that time. In Pennsylvania, these private water systems, and I do realize there's folks from all over the country here, and I'm going to try to keep it as non-specific to Pennsylvania as possible, but just to give you examples, here in Pennsylvania, we have roughly 1 million private water systems. That map in the top right shows a map of at least some of the water wells in Pennsylvania. So they're very densely located all across the rural areas of the state. Roughly 90% of these are drilled wells in Pennsylvania. About 10% are either springs or cisterns. In most states, all management of these water supplies is voluntary. So the homeowner is responsible for everything with these water systems, the testing, the treatment, the management, and even the construction. In some cases, in Pennsylvania, we're one of the only states that don't regulate even the construction or the location of private water systems. So here in this state, we're basically entirely voluntary. The homeowner is responsible for everything from the very beginning of even hiring the well driller and deciding where to drill the well and even deciding on the construction. We have a couple of counties that have standards, but most of the state does not have any kind of regulatory enforcement or ordinances. For that reason and for a variety of reasons, we have lots of pre-existing problems in private water systems, and we'll talk more about why those occur here in a moment. But these are some of the pre-existing issues that we see. The red are health-based issues, the blue are aesthetic issues, and this is showing the percent of private water systems in Pennsylvania based on numerous research projects that we've done that fail drinking water standards for these individual parameters. The only one I'll point out hardness on here, which is one of the blue, it does not have a true standard, so that's just showing water that's considered hard, but the rest do have standards. And so in the red area, the health-based issues, in Pennsylvania, about 40% of our private water systems have some sort of health-based pollutant above a drinking water standard. Most of those are coliform bacteria, but other significant ones like lead, E. coli bacteria, arsenic, nitrate, barium. We could put a whole bunch of other red bars in there, less than 1% for things like pesticides and volatile organics. Mainly these are things that are coming from activities. Some of them can be naturally occurring, but they're often from nearby activities. And another significant component of those is a lot of these health-based pollutants don't have any symptoms in the water. They don't smell, they don't taste. And so the only way you know that they're there is to test. And because of the lack of testing, sometimes the awareness of these tends to be very low. Now on the aesthetic side, in the blue bars, these people tend to know more about because they usually have an obvious symptom like a stain or a taste or a smell. And so people are much more aware of these. Testing just kind of confirms that they're there. But examples would be something like iron, shown in that picture, where iron is clogging up a filter. And aesthetic issues affect about 2/3 of the private water systems. A lot of these are very minor issues that people don't even treat the water for. For example, hard water can be an aesthetic issue that a lot of people just choose to use the water even if it's very hard. So why do we have all these pre-existing problems? Well, some of it's inadequate construction. So here's examples of water wells that have coffee can well caps or have big holes next to the casing where surface water can put a lot of bacteria and sediment into the well. Sometimes it's what's happening right around the well, whatever the well owner is doing, tying the dog to the well casing or having animals right around the well, putting fertilizers and pesticides right around the well. There can be all sorts of activities done by the homeowner or the neighbor of the homeowners that can affect the water well, especially if it's poorly constructed and it's easy for these contaminants to move down along the casing. The second picture is a well right next to a parking lot where you can see runoff coming off that parking lot going right in around the well. Natural geology always plays an important role. Is it limestone, sandstone, shale, crystalline rocks? In Pennsylvania, we have all those, and those play a tremendous role in determining what the natural water quality is going to be. Is it going to be hard water, low pH water? Is there going to be iron present? A lot of that is dictated by the kind of rock that you've drilled into. And then finally, we have these larger scale land uses, mining, gas drilling, agriculture, urbanization. All of these things can also affect groundwater with a variety of pollutants. Because of all this, a lot of folks have installed water treatment devices. And these become very critical when we talk about water testing, because typically when we're trying to document conditions of groundwater prior to gas drilling or any other activity, we want to make sure we're getting raw water that's not going through a treatment device. And in Pennsylvania, for example, we know that about 53% of the people that have their own water supply have at least one water treatment device. And so we need to be cognizant of that. We need to recognize those, and we need to make sure that we're collecting water prior to those devices so that we're truly getting water coming out of the ground, not water that's being influenced by things like sediment filters on the left or a softener in the middle or a UV light and an RO filter over on the right-hand side. A lot of these things are installed for aesthetic problems, but in some cases they are for health issues. But the important thing, again, is from a water testing perspective, we need to identify those and make sure we're testing ahead of those. Normally that means testing at the base of the pressure tank where the water enters the home prior to going into any water treatment. If you're lucky, there might be a spigot right out at the well where you can sample outside the house even before it gets into the pressure tank. As far as options for water testing, first of all, there are a lot of accredited commercial laboratories all over the country. In Pennsylvania alone, we have about 36 commercial laboratories where you can go and get water tested. In some states, regulatory agencies do water testing. Here in Pennsylvania, DEP will provide bacteria testing for homeowners, and they'll provide a lot of other testing when they get involved in enforcement action. Where health departments exist, they may provide water testing. There's also lots of home water test kits out there. We always tell people to be very cautious about those. For some things, they can be fairly accurate, but for other things, they can be very suspicious. And we really tell people if you're going to use a home test kit, that's fine as a starting point, but you really want to confirm results with an accredited lab if you do happen to get some results from a test kit. Types of water testing really important when it comes to pre-drill testing for gas drilling as opposed to just educational testing. And so educational testing, that's where a homeowner collects a sample or somebody in the home or somebody associated with the homeowner collects a sample and delivers it to a lab. And that has limitations because it's not being collected by an independent professional, so it has really no legal value. It's really just for education. And the parameters are chosen by the homeowner. It's usually common things like bacteria and nitrate and lead. It's usually low cost testing, maybe $100, maybe a couple $100. And it's really solely for the education of the homeowner, typically to determine if their water is safe and if they need to buy water treatment equipment. And it's fine for those purposes. Then we get into what's called third-party or chain of custody testing, and this is what really applies to pre-drill samples for gas drilling or post-drill samples or any kind of cases where you're trying to legally document the water quality. The important component here is that the sample is collected by an unbiased professional. That's often an employee of an accredited lab, or it's an environmental consultant working with the lab who comes out to the home They collect the sample in a professional manner. They're unbiased so that we can trust the results. And the homeowner never touches the sample. In fact, there's a chain of custody form that shows who collected the sample and who touched the sample from the time it was collected until it goes through the lab process. We still use accredited labs for this, although sometimes fewer labs will get involved in this process. We have lots of accredited labs in Pennsylvania that don't offer third-party collection. In other words, they don't have employees that go around collecting samples. They may accept samples from a consultant as a third party, but the number of labs often drops when we're talking about doing this kind of testing. We can often have much more extensive sampling lists in this case because the sampling is often being done for legal purposes, and legal is a very important component of this. We are truly legally collecting a valid water quality condition sample of that water supply. And it's absolutely critical if this were to ever go into a legal case or a regulatory case. One of the first things that will be looked at is how was the sample collected? Was it done appropriately? Did it go to an appropriate lab? Who handled that sample? And were they all unbiased professionals? If we look at that educational testing just for a moment, here in Pennsylvania, for example, we know that a lot of people never do this testing. Again, it's all voluntary. And so in Pennsylvania, 30% of our private water system owners have never tested their water. 44% have only ever done it once, usually when they were purchasing the home, and 26% occasionally test their water. And only about 9% do it every year, which is what we truly would recommend people do, is at least do some testing every year. 2/3 of these folks use commercial labs, which means a third, and they're using accredited commercial labs, which means a third are mainly using non-accredited labs or other sources like in-home test kits. Some of the barriers, why don't people test their water? Cost is an important one. We've done surveys that show a lot of homeowners begin to balk at water testing when it gets up to about $100 to $200, and that's not hard to do with water testing. It only takes a few parameters to get to that cost limit. So cost is a big one. Availability. If you don't have a lab within 30 minutes or an hour of you, you're less likely to drive that distance to get the water testing kit and then drive back and deliver it to the lab. The third one's incredibly important, recognizing that you even need to sample. For a lot of people, if the faucet turns on, the water runs, it's clear, it doesn't smell, I don't have any obvious health problems, I just assume, hey, the water's fine and I'm not gonna get it tested. In fact, we've had lots of people say, hey, I don't wanna know. I got enough problems in my life. I don't wanna know what's in the water. It smells okay, it tastes fine, the water turns on, I'm good with it. And that, we can certainly understand that viewpoint. The final barrier is interpretation. We find folks that get their water tested and then they get frustrated because they can't understand what the results mean. And this leads to a real lack of awareness. All of these barriers lead to a lack of awareness of problems. People just don't know that they have water problems because they've never tested for a variety of these reasons, or if they did, they didn't understand the results. The one thing about shale gas pre-drill testing is that it overcomes these barriers. The cost is often paid by the companies or regulatory agencies. It's available because they come out and do the testing for you. You don't need to recognize the need because it's recognized for you. Interpretation, though, that's where one of the problems can come up. In most cases, the results are provided to a homeowner or to an energy company, but there's typically not much, if any, interpretation of that. And there's a variety of reasons for that. When we look at industry-sponsored pre-drill surveys, which most states have some sort of regulatory condition where this is done, in Pennsylvania, this is done mainly within 2,500 feet of a shale gas operation, although some companies voluntarily extend that distance 3, 4, 5,000 feet out from the operation to do this testing. So it's going to be done on private water systems within some distance around the gas drilling site. It needs to be done by an accredited lab and it needs to be done by chain of custody. The parameters, at least in Pennsylvania, are chosen by the gas drilling company, so it can vary. Some companies do much more extensive testing than others. In some states, that list of parameters is specified and they're all the same. It is free to the homeowner and the homeowner gets a copy of the results. This involves what's called presumed responsibility in Pennsylvania, and numerous states have this presumption where the private water systems that fall within this 2,500-foot area are presumed to be the responsibility of the gas drilling company if there's any water quality problem. So basically, any problems that happen within that circle are assumed or presumed to be the responsibility of the gas drilling company. And because of that presumption, the industry has a very big, important role here in that they want to know what the pre-existing conditions are. I just told you a few slides ago, we have all these pre-existing conditions. And so from the industry perspective, they want to know what are those pre-existing conditions before they drill, so that if anything is complained about, they have that listed already as an existing condition in that water supply. So that's the industry interest here, is let's document what are those pre-existing conditions by doing this pre-drill survey or pre-drill testing. This has changed a lot. Here in Pennsylvania, it's changed a lot over time. On the left there was a typical pre-drill water test from 2009. A lot of them were one page, and they were maybe a dozen different parameters. By 2012, on the right, you see 6 different pages there, and that's just some of the packet of water test information that was given to the homeowner. These days, some of these pre-drill tests are 30 and 40 pages long, with lots and lots of different parameters. So the list of parameters has increased, the complexity of the water testing, the documentation of the water testing has definitely increased dramatically over the last 5 to 10 years. Now, what about homeowner pre-drill testing? So we talked a little bit about these industry pre-drill tests. Do homeowners ever do pre-drill testing? And sure, they may want to do it because from their perspective, they want to document how good their water is prior to drilling, right? So the industry wants to document pre-existing conditions. The homeowner also wants to document, hey, my water didn't have chloride or barium or methane in it prior to the gas well. So everybody's got their perspectives, but in the end, we're all doing the same process, basically, of using chain of custody. So even with homeowners here, we want to use chain of custody, but we have some considerations. First of all, is testing going to be done for me by the gas drilling company? Am I in that 2,500 foot circle or even outside the circle? Is the industry going to test for me? Then if they are, I have to decide, do I trust that data? And we have no reason to tell people not to, but some folks inherently aren't going to trust information that's being paid for by the industry, so they may want to do their own test on their own dollar, and they can certainly do that. Then they have to decide how much can they afford. And like I said, it doesn't take much to get into many hundreds of dollars. When you're talking about a comprehensive water test, it may be $1,000 to do a really comprehensive pre-drill test. And then when to do this, we don't want to be testing years before the drilling. So we need to have an idea of when the drilling is going to occur, because we want that pre-drill sample to be as close as possible to before the start of drilling. We don't want it to be certainly not years and hopefully not even many months prior to that drilling starting, so that we're getting a good snapshot right before the drilling. So in these cases, again, if homeowners do decide to do pre-drill surveys, they do need to use accredited labs, they do need to use chain of custody, and they need to figure out how much can they afford and talk about which parameters they're going to test with the lab and with other experts to get the most bang for their buck as far as getting the best parameters tested. This is probably the most common question that we get. What do we test for? Again, in a lot of states, this is all dictated in regulations for the industry, but for homeowners, this is the most common question. I've got $200, what do I test for? Or I've got $400, what do I test for? In Pennsylvania, they have a fact sheet where they've put out recommended parameters, and they've done a tiered approach where they have bolded, and I have them red squared here, the most important, so that if I only have maybe $200, I would do those first. But if I have 400, I would do everything on the list. And that would give me a pretty good snapshot of what the water quality conditions are prior to drilling. And I can even compare those with the pre-drill surveys done by the industry. And we've done a lot of that and find that they're very comparable. But again, it gives some homeowners more trust in the information if they've not collected it, but if they've paid for it and hired their own laboratory to do it. These are just some more details. Other agencies, including us at Penn State, we came up with a 3-tiered approach where we had a basic list of parameters like total dissolved solids and chloride and barium and methane and iron and manganese, which provides a pretty good basic water test for a couple $100. It's going to give you a little less legal protection because you're only focusing on some of the most critical and most likely contaminants. If we add in things at a moderate level, like we saw in the DEP fact sheet, we'd be looking at things like perhaps sulfate and bromide and sodium and hardness, calcium, magnesium, a variety of different things. And these parameters, I should say, could vary state to state depending on what sort of natural issues you might have. These are examples from Pennsylvania again, and they undoubtedly would vary a little bit as you move around the country. This gives you a little bit more legal protection because you've expanded your testing. And then finally, you might get into more expensive things like BTEX and other volatile organics and radionuclides, and that's where your testing can maybe approach $800 or $1,000, but you're getting even more legal protection because you've expanded your testing to include really pretty much anything that you might expect to see. In a nutshell, the more testing you do, the more protection you're going to have, but the more money you're going to pay for it. And so it becomes a discussion between the homeowner and the water testing labs and other professionals about what can I do most efficiently for what I can afford. Then the question becomes how many pre-drill samples? In a lot of regulatory environments, there's the requirement for one pre-drill sample. This is the most common scenario where you're going to do one sample prior to drilling. That's going to document the pre-existing conditions. It's the standard method. It's going to be the cheapest because it's one sample, and we're going to be able to generally use that to detect large changes in water quality that might be beyond variability that you might expect seasonally or naturally in a water supply. So you might not pick up very subtle changes by doing this, but you're going to pick up anything very major that occurs. If we do multiple pre-drill samples, then we're going to get a really much better scenario of what are the natural variations in that water, so that when a change occurs, we can see if it is truly within the natural variability or is it beyond that natural variability. This requires a lot more time because you have to get multiple samples over different seasons, and it's going to cost more money. And frankly, it's not done very often, but it's by far the best thing to do if you can, because it really helps you get a much better picture of what the natural variability is of water quality. And all water supplies have natural variability. None of them are going to be stagnant in time and have the same water chemistry. The chemistry might change very little. In some other ones, it may change quite a bit. And the ones where it changes a lot, that's where having these multiple samples can be very helpful. So for the rest of the time here, let's look at some water test interpretation. And first of all, I said earlier that one of the things that we hear from homeowners is it's very hard to understand these and they get frustrated. In fact, the surveys that we've done, 60 to 80% of the landowners that we surveyed said that the water samples that they got either from pre-drill testing by the industry or where they hired labs to do the testing themselves, they found those results to be very difficult to understand. And not surprisingly, when you look at these very complicated sheets, even myself, I've done this for decades now, and it still can be very challenging to look at a water test report. It takes a while to get your bearings about exactly how is the lab presenting things, what was done here, and it can be very challenging, especially for a landowner. Think of yourself, even if you've done this kind of work where you've interpreted water tests, what if you went to the doctor's office and they tested your blood, and when you went back to the doctor's office, they handed you a sheet with the blood test and said, there you go. And your obvious question would be, well, is it okay or not? And they would say, hey, I don't know. You need to look at it, you figure it out. And that's often what happens is water test results are handed to somebody, and I understand that the lab's job is to test the water, not to interpret it. But still, there's the interpretation phase of this, which can be very difficult, and which is one of the big reasons we're here today. So with interpretation, we find fewer and fewer entities and people are willing to do this. One of the main reasons is liability. They don't want to be the one to tell somebody that they need water treatment or don't need it. So we see fewer labs doing interpretation and fewer government agencies doing this as well. Reports have become longer and more complicated as well. So we see that from the pre-drill surveys where there used to be a couple pages or a page, now there are 30 pages, very daunting. One of the hardest parts sometimes is just figuring out where your results are in that booklet that you are given by the energy company, or that the lab gives to the energy company. Where are the actual results in all of this, because there's so much other data. It is important to understand them. They are legal documents. They may ultimately end up being used in a legal case. So it's important to understand what they're saying, both from the energy company perspective and the homeowner perspective. They need to both understand what are the pre-existing conditions that are there. And if you disagree with them, you may want to collect additional data before the drilling goes forward. There is no standard format, at least here in Pennsylvania. I don't know if that's true in every state, but we have no standard format for water test reports, which leads to a lot of complications. Different labs present things differently, even though they may have all the same basic components. They put them in different order, in different places. They call them different things, and that can become challenging. Interpretation can vary for some of the water quality parameters. Methane is a great example. Methane doesn't have a drinking water standard, so it's open to a lot of interpretation. Some people will say, if you have any methane in your water, you have a potential problem. Others will say, methane doesn't have a drinking water standard, so I'm not going to worry about it. So even if there's a lot of methane in the water, I'm not going to tell anybody about it because there's no drinking water standard for it. And we fall back on drinking water standards for a lot of this. So that's just one example where interpretation can vary depending on perspective, especially for things where we don't have drinking water standards to go by. We and others have adapted lots of different online tools and publications to help people interpret water test reports. This happens to be ours. Lots of other states have these now, where you can go in and plug in your water quality results to an online form, hit enter, and it spits out an interpretation for you. And it'll even link you up with fact sheets. If, for example, your water had bacteria in it, it'll link you up with a fact sheet about what is this bacteria, where does it come from, and how do you treat it. So lots of these are available. I just show ours as an example, but they've been very helpful to people. But the caveat is they're only as good as the information you put in. And so it's important to recognize things like the units, milligram per liter versus microgram per liter. And all of that text at the bottom of this online form is basically explaining how careful you need to be in putting your data into this form in the correct format so that you're making sure you're getting the correct results out of it. So let's look at some water tests, basically the components of water tests first here, and then we'll get into some actual examples. So a lot of times now there's a cover letter, which will explain a little bit about the water testing. There will typically be the actual results from the water supply that was tested, and it might be 1, 2, maybe 3 pages of actual results. Then there's going to be probably a whole bunch of pages of quality control, quality assurance, QA/QC data. That can be dozens of pages in many cases. That's important data. It's basically documenting the quality of the data, the laboratory quality, the field quality of the data. It can certainly be useful if there's ever a question about the data, but for a lot of homeowners, it's just filed away and they pull it out if they need it. But really, the number 2 there, the results, is the most important thing. Although there will typically be a copy of the chain of custody form, which shows who all collected the sample, how was the sample handled after it was collected, who accepted the sample at the laboratory, and who handled it at the laboratory. So it is a true chain of custody, the chain of people that had custody of that sample, everyone that had exposure to that sample, and they should all be unbiased people, and they should all be professionals, basically, is the hope. And then there can be sometimes supplemental materials. So some companies will put in fact sheets that come from independent organizations. For example, if somebody has methane in their water, they might include a fact sheet from a regulatory department or from a nearby university about methane in water and how to get rid of it. So that varies depending on the situation. Within the actual results of a water test report, one of the things that some labs will report, and a lot of labs actually don't report these anymore, but some labs will include drinking water standards. And these are basically the government standards for particular parameters that tell us how safe is the water, or the acceptable level. So research is done internationally over many years on things like, let's say, lead, for example. And we determined that lead has a drinking water standard of 0.015 milligrams per liter, and that's the same as 15 micrograms per liter. So that is sort of a drinking water standard where we say if you're above 15 micrograms, you've got a problem. If you're below, it's within the standard and it's considered to be safe or acceptable. And we have different kinds of standards. These are enforceable standards for public water supplies, but again, for private water supplies, they're not enforceable. Primary standards or health-based standards, these are things that cause health problems like barium or benzene or bacteria or lead or arsenic. There are many dozens of parameters that have health-based standards, which means if your water is above these standards, you've got a health problem, a potential health problem for that particular pollutant. There are secondary pollutants, which are sometimes called recommended MCLs or secondary MCLs. These are aesthetic problems like chloride, which makes the water salty, or iron, which makes red stains and metallic taste. And there's roughly a dozen of these kinds of standards. Also on water test reports, we have these units, which I alluded to, milligram per liter, microgram per liter. There's a factor of 1,000 between those, so you move the decimal place 3 places, depending on whether you're going from microgram or from milligram. And there are other things that have special units, like bacteria, which is often in colonies, or you'll see it as CFU, colony forming units per 100 milliliters. It may also be a MPN, which is a most probable, that should be most probable number of bacteria. A pH has its own units. Hardness can be grains per gallon. Radionuclides are in picocuries per liter. So there are a handful of things that have their own units, but by far the most common are the milligram per liter or the microgram per liter. And then there are also comments, qualifiers, and flags, which can cause a lot of confusion. We spend a lot of time answering questions about these. One of the common ones is, what is this MRL or DL on a report? And that is the method reporting or the detection limit. This is basically the smallest concentration that the lab's instrument can detect or report. So we can never really measure down to 0 because the instruments that we have, they don't have the ability to measure down to 0. They have the ability to measure down to very low numbers. So for example, lead, we might have a drinking water standard of 15 parts per billion, and our lab instrument might be able to measure all the way down to 1 part per billion, but it can't measure any lower than that, at least not accurately. So 1 part per billion would be our reporting limit or our detection limit. That's the lowest that the lab can measure. And so you'll see these detection limits or reporting limits on a lot of water test reports, and they cause a lot of confusion because many people think they're drinking water standards, and they're far from that. They're actually very low numbers that are telling us how low the instruments can read. Related to that then is when we have results that are below these detectable limits, the labs will put ND for not detected, or they'll put a less than sign and then the actual detection limit. So for lead, they might put the less than sign and then 1 part per billion, which just means we didn't detect any, our detection limit's 1 part per billion, so we're putting a less than sign there, meaning if there is any lead in the water, it's less than 1 part per billion. And they may also put a BD for below detection. So those are all basically the same thing, and different labs will use one of those acronyms. And then finally, there can be flags or qualifiers, and these are things like, the water was too warm when it got to the lab, it wasn't on ice, it violated a holding time, which means it took too long to get to the lab. It should have been here sooner for us to accurately collect, or for us to accurately measure the pH or the bacteria or whatever it might be. Or there might have been a problem with the quality control data, and they'll put a flag in saying, hey, the quality control data wasn't very good for chloride or for sodium. And these flags can cause a lot of confusion as well. So for the rest of the time here, I want to show you some examples. This is a very simple water test report. This is done by Penn State's lab. Our laboratory is very much focused on educational water testing. So it is our main objective and focus to make these as understandable as possible for the homeowner who's buying these water tests. So on this, you see in the red, the second column has the units, mostly milligram per liter. The left-hand column here is the analysis. So it starts with total coliform bacteria, goes all the way down to zinc. The middle column here has the actual results for this water supply, and you see that a lot of them have this less than sign and then a small number. So the Penn State lab chooses to report very low numbers as less than and the detection limit. Other labs might put an ND or a BD in that case. Right next to the results are the drinking water standards. And again, because it's our objective to make these as understandable as possible, we put the drinking water standard right next to the water test result. So all you have to do is compare the third and the fourth column. My bacteria was 18, the drinking water standard is 0. I've got a problem with that, it's too high. And even right next to that, it tells me, is it a health standard or an aesthetic standard? So I know I've got a health concern with bacteria right off the bat. I can look down to something like barium where I've got less than 0.002. The drinking water standard is 2 milligrams per liter. I don't have a problem there. I'm way below the drinking water standard. And if folks don't even want to look at the results, they can look down below it, and we tell them what things were above a drinking water standard, and it gives them information about who they can call. So this is kind of the far end of the spectrum about making the results as understandable as humanly possible. Lots of folks still have questions about this. For example, they might want to know, how do they treat bacteria? We can't put that in the table, but they at least know they have a problem with that, and they can then determine where they need to ask further questions. Now we look more at what's probably more typical kinds of water test reports that you would see for baseline testing or pre-drill surveys that are done related to gas drilling, where the water testing labs, their focus is to test the water and report the results. So they rarely will include drinking water standards, and they're more likely to include these detection levels or reporting limits. And that's what you see on this report. Again, on the left, we have all the different analytes that were done. And you see in the results, which are the second column, now we have all these NDs. So this lab chooses to use an ND acronym to mean they did not detect any oil and grease. They did not detect any suspended solids or turbidity or ethane or propane. Next to that are the various flags. And these are the comments. Some of the things that are very common to have a flag are pH, because pH really needs to be done in the field to meet the holding time. And so it often has a holding time flag, because if it's done in the lab, it's going to violate the holding time. And that's what you see here. We have a holding time violation because it was done in the lab, not in the field. Also, you see the reporting limits, and this is where the confusion comes in. The fourth column, or excuse me, the fifth column has the reporting limits. So for the first one up here, bicarbonate alkalinity, we have a result of 248, and we have a reporting limit of 10. For people who think that's a drinking water standard, they start to get very upset when they read down these numbers and see that pretty much all of their results are higher than that number. And if it's a reporting limit, they really should be, because the only way you're going to report a number is if it's higher than the detection or the reporting limit. So what this is saying is the lab instrument can detect down to 10 milligrams per liter of bicarbonate alkalinity, and the result was 248. It says nothing about whether it's safe or not, or whether there's an aesthetic issue. It just says it was there, here's our detection limit. And the detection limit gives you kind of a rough idea of how low the instrument can go. So for something like, let's see, chloride, the 13.2 is the result, and 1 is the reporting limit on here. Another thing that causes a lot of confusion is when we do organics and labs put what are called surrogates on the report. And in this report down here in this arrow midway down, you see SURR, acetylene, and then a percentage range. Surrogates are not things that are in the actual water sample. They are a method of quality control. And they cause a lot of confusion because the surrogates are often placed in the actual water test report with the actual results. And so someone might read this and think, my gosh, I've got acetylene in my water. And they start Googling what is acetylene, and they get very concerned. When in fact, there is no acetylene in this water. It's used as a surrogate quality control for the methane, ethane, propane testing that was done. So surrogates cause a great deal of confusion. I actually wish they would be put in the QA/QC portion of the water test report, because then they wouldn't be confused with actual results that are in the water sample. Here's a different laboratory that shows reporting limits. So here we're showing the detection limits. We've got a qualifier for pH. They use an R acronym to basically say that it was done in the lab and not in the field. All the way down at the bottom, you see bacteria results, and you notice that for a lot of bacteria, they'll report absent. Because they can't really say 0, they say absent, which again is just another method of saying there was no bacteria detected in the sample. Here's another report, and you see how these all look very different, right? They have same basic information, but they all look very different, and they're in different orders. And sometimes the reporting limits are second column, third column, fourth column. But in this particular one, I just wanted to show you the different flags that are on here and what they actually mean. So we've got an F flag for methane, which says that there was a blank recovery issue, which is a quality control concern. That's something we definitely would want to know. It's got an M1 calibration, which means there was a calibration problem potentially. And it's also got an H issue here. H is a holding time issue analyzed outside of the holding time. So these acronyms are important, and there should be a definition of them in with the water test report. And again, unfortunately, they're not often standardized, so they vary by lab, and you just have to look at whatever table they have to find out what those acronyms mean. In this particular case, they do put an X if it violates a drinking water standard. So they don't actually give you the standard, but they tell you by an X that yes, 9.1 turbidity is too high and 1.3 milligrams per liter of iron is too high based on drinking water standards. The quality control, quality assurance data, this includes things like blanks, duplicates, and standards. This is basically ways to make sure that the lab is producing accurate and reliable data. And I'm not going to spend a lot of time on it. It's a big part of a lot of water test reports, and it can get very confusing as well, but blanks are basically distilled water, and they want to make sure that the instruments aren't reading any background contamination. Duplicates are where you submit 2 samples of the same thing and see how repeatable the lab is. And standards are where we take a known concentration and give it to the lab and see if the instrument actually measures the correct concentration. So I can buy standards that have 500 milligrams per liter of chloride, and I can give it to the lab as a blind sample and see if their instrument actually reports roughly 500 milligrams per liter. So for blanks, we might see a report like this, and for blanks, because it's distilled water, we should see a whole bunch of really low numbers, and we do. We see lots of less than signs here, which is great. That means the blanks worked out perfectly. For duplicates, we should see 2 numbers, and they should be very comparable. And they're never going to be identical, or very rarely identical, but what we want them to be is very close, and the relative percent difference is what's important. And we usually look for very low percentages here, like 1 is great, 5 is very good as well, 0 is wonderful. That's where you actually have the exact same number. But less than 10% is really, really good relative percent differences for these different water quality parameters. Last thing we want to do is interpret some water test reports here. So what if we have post-drilling data and we're trying to interpret whether anything has happened? So ideally, it's great if we have, first of all, at least 1 pre-drill survey, and it's wonderful if we have more than 1 pre-drill survey to compare to. What that allows us to do then is look at changes that occurred in the water, and additionally trying to determine if those changes are beyond what we might expect based on natural variability from weather and season. And again, that gets easier if we have more than 1 pre-drill sample. We want to see if the changes occurred at the right timing. So when did drilling occur, and did these changes occur after that drilling in some reasonable amount of time? And also, did the changes violate drinking water standards? So did the water go from acceptable water quality to now violating drinking water standards? And that's an important component as well. So here's just a couple examples. These are actual results from years ago, actually, but we have a pre-drill survey shown on June 9th. We have a July 30th sample, a July 31st, and then an August 6th sample. And what you notice on these samples, if you look at something like total dissolved solids, it went from 25 milligrams per liter in the pre-drill to almost 3,000 on July 30th. Then it came down to 1,500 and 1,100. Similar kinds of results for chloride and for barium and for hardness. And this is a sort of a classic contamination signal where you have very clean water going to very dirty water and then slowly kind of coming back down. And you see where it went very high July 30th and then starts to slowly recover back down. And if we monitor it long enough, hopefully it'll come back down to the pre-drill conditions. So this is kind of a cut and dry, about the easiest case you'll see of, yes, something happened here very dramatically. Was it gas drilling? Well, if gas drilling happened within that time frame and was nearby, then we can make a better case for that. Here's another case very similar where we have very, very highly contaminated water, but we don't have a pre-drill sample. Now it is tailing down like we would expect, but you can see how it makes it very hard, even though the changes are very, very noticeable. The water quality is very, very poor, but how do we know it wasn't like that before? And how do we know that this coming down isn't part of the natural cycle of that variability? So not having any pre-drill data, it doesn't make it impossible to determine what happened, but certainly makes it a lot more challenging. And then here's another one where we have a pre-drill sample in December, a complaint in April, and then another follow-up in July. And really about the only change here is a very small change in iron and manganese, where it went from 0.11 iron to 0.5 and 0.038 manganese to 0.144. Those are significant because they go from below the drinking water standard to above. But the other issue here is those are very typical changes that might occur just with season and with climate changes and with somebody drilling a water well nearby or some other land disturbance nearby. There can be a million different reasons why that kind of a water change would occur. And that's where only having 1 pre-drill with this subtle change makes it very hard to determine what might have happened. Yes, it could be drilling, but it could be a lot of other things also. So keep in mind that those single pre-drill samples, they make it easy to detect those big changes and more visible changes, but these very subtle changes that have lots of different reasons for them, especially things like iron and manganese and sediment, those are very common things that vary and can be very difficult to document what might have happened. Lastly here, this is a pre-drill example. This is again a very complex water sample done May the 12th, 2010. And if you look down through these water quality results, if you happen to know drinking water standards by heart, if you look down through there, you'll see that this is very excellent water quality. It really meets all the drinking water standards. It's very typical water quality that we might see in a groundwater well in Pennsylvania. It's got a pH of 7.3, a moderate total dissolved solids, really pretty good water quality, and no detectable methane, ethane, or propane. Now, if we look at a post-drill done several months later after drilling had occurred, the red numbers were added on here. Those are the pre-drill samples from the result I just showed you. And if you start looking down through them, first of all, the general chemistry above, you don't see a whole lot of big differences. The carbonate's about the same, the chloride's roughly the same, the pH is similar, the conductance, the sulfate, the TDS, they're all pretty similar, as are the metals down here at the bottom. But the really noticeable one as we look at this is the methane, ethane, and propane. They went from all non-detects to all detectable and significant concentrations. For methane, 17.5 milligrams per liter. That's a concerning amount of methane, in addition to the combination of ethane and propane being present when they were all non-detects. So here is a case where a methane migration issue could be fairly easily detected with a single pre-drill sample because they were all non-detects and they went up pretty significantly afterward. So to wrap up here, we do have lots of other resources on our website related to this, different fact sheets, short videos, even some recorded webinars available on the Penn State Extension website, just extension.psu.edu/water. If you have interest in learning any more details about water test interpretation or chain of custody water testing or interpretation of these kinds of water tests, these might be helpful to you. And with that, I'll be glad to answer any questions. There's my contact information as well if you have any follow-up questions for me. Any questions?
Thank you, Bryan. That was really interesting, and I always learn as many. I've been through a few of your presentations before, and I always learn something new. So thank you for that very much. Hey, there are three. We've got 3 questions, and if there are, and I don't know if you can see them, Bryan, in the Q&A pod, but for those of you that have been here watching the presentation, there are 3 questions in the Q&A pod. If you have a question that's lingering that you'd like to stick in there, we do have a couple minutes before the hour is over. Please go ahead and put them in the Q&A pod. And I would bet that fairly shortly, Dana will put on cue, we'll put up a poll with just a couple questions, and we really would appreciate if you just take a moment and respond to that as well. And if you'd also tell us something you'd like to hear in a webinar that we haven't done, we really would like to hear that too. So with that, Bryan, can you see the questions in the Q&A pod?
I did see the first one for the poll one up there. It was about radon testing, and it's become very common to do radon testing in indoor air as part of real estate transactions and so forth. And I believe the question was about whether, well, I guess I can move these things so I can see it, has become mandatory. Is radon soluble in water? And if so, is it harmful? Yes, radon is soluble in water. It's a dissolved gas, just like methane, for example. So it does come out of the water very easily. That can be a problem, although in most cases, radon in indoor air comes mostly through the foundation. You can have cases where you get significant amounts of radon gas in your home from your water. And as you shower, for example, the radon gas will escape out of the water. So it can be every bit as harmful as the radon coming in through your foundation, although it's a less common issue. We usually suggest people start with indoor air testing. And then if they're just not able to solve their indoor air testing problem through foundation work, they may want to follow up with water testing. And I see a second question, can dilution factor used by a lab adversely affect accuracy of a reported lab result? Well, yeah, it would. If you dilute it down, then you do tend to affect your, not so much your accuracy, but your precision. How low can you detect things, for example, might be affected by that dilution, although it's absolutely necessary in some cases where you have really high concentrations. And normally where you have those high concentrations, you kind of swamp that loss of accuracy by doing that. Pump time on well before sample water table level. Oh, how long do you, I guess the question is, how long are you pumping the water before you collect the sample, maybe is what that question is. And there are criteria for that. A lot of times they'll suggest trying to remove at least 3 boreholes of water, and it can get very sophisticated. A more standard approach is to use field devices like pH and temperature to watch for stability of those parameters before you collect the actual sample. In a really simplistic model, you may run the water for a set period of time, like 10 or 15 minutes, and assume that you're purging all the water, at least 1 well volume by doing that. So there are different scenarios and different levels of sophistication. Ideally, what you'd like to do is purge several volumes of the well before you actually collect a sample, and you want to look for some of the water quality parameters to be stable before you actually collect that sample. What problem test result would be your first concern with a pond test? With pond testing, the most common issue is typically sediment, which is usually apparent, but we still have to quantify it. But it's usually a surface water runoff issue due to disturbance that affects ponds. Beyond that, probably total dissolved solids would be a second test to watch, to look for more invisible things that might be affecting the pond. What is a typical penalty or corrective action required of drilling companies if water quality is negatively impacted during drilling? That's going to vary a lot state to state, but I guess probably the most typical case would be that water supply replacement will be required. It's often required initially while the investigation is occurring, and then once a determination is made, they may determine that the water supply does need to be replaced. That can either be through treatment or through hooking on to public water or drilling a new well, if that's going to work. There's a variety of ways of basically returning the water supply back to what it was, either through treatment or replacement. General time frame for homeowners to learn about gas drilling in their area in advance of operator activity. Do homeowners have enough time? So here in Pennsylvania, again, there are regulations about notifying water supply owners within, I believe it's still 3,000 feet from a gas drilling operation where they're going to drill. They must notify out to 3,000 feet. Somebody can help me in the chat box maybe about the time frame for that in Pennsylvania, or other states, feel free to chime in. But yes, typically they have plenty of time then to get those pre-drill samples collected. It's not like they can notify you today and then start drilling tomorrow and not give you time to collect those samples. I'm building a new home and getting ready to drill the well. Are there any questions that I should ask the well driller? Is there a place that I can check? And I guess, Brent, it does depend a lot on the state that you're in. Here in Pennsylvania, again, without regulations and requirements, it is very important to do some homework. There are lots of online resources, including on our website, about things to look for when drilling a well. We have a whole brochure on that. It's called Before You Drill a Well, and you might want to look at that on the Penn State site. In other states where there are more regulations, it's less of an issue because a lot of that is kind of in the regulations about what needs to be done. But you want to ask questions like construction of the well and location of the well and not warranty, but the insurance for the well driller, all sorts of things that can go wrong. And we have that all in our publications. What would cause turbidity to come and go in my well water? Lots of different reasons. A lot of wells vary because of rainfall. If you have a lot of surface water entering your well when it rains, that's going to carry turbidity. So a classic case is where the well gets cloudy after it rains and then clears up. Some people notice their water gets more cloudy when they use more water, and that usually means that they have built up a bunch of sediment below their pump. And so as the water gets lower and lower as they're using it, it starts to stir that water up. So those are just 2 common ways, but there can be lots of other reasons for it as well. What testing parameters might you add when dealing with oil well drilling? It's really a lot of the same components. We don't have near as much of that in Pennsylvania, so I don't deal with it nearly as much as we do gas drilling. but it's largely a lot of the same components. Oil and grease is a standard test as well. Total petroleum hydrocarbons would be an important one. When you test pay in field, are you just using the handheld meters to do so? I'm not sure about that one, I guess, but what I was meant about the testing in the field is they typically will use that to determine if they've run enough water to collect the sample. And what they're looking for is that you get a stable pH and temperature and conductance. Those are probably the three most common things that you'll use handheld meters in the field to measure the water while you're running it before you collect the actual sample. So those are probably the three most common parameters. Any parameters to check for possible contamination from a frac. A lot of the parameters we talked about, that's what they're focused on. Some specialty things like ethylene glycol sometimes gets added in, but really things like TDS, which is going to be very high in frac water, chloride, barium, those are sort of standard ones. A lot of those other frac chemicals, concentrations are very, very small, and it's hard to rationalize how you're going to get those chemicals without all these other ones that are much easier to test for. Let's see, of state required sampling programs that I've seen, most post-drilling sampling is required after a certain time has been completed. Are there any states that use rate of groundwater flow for determining when domestic wells should be sampled? And we don't require that here, and I don't know enough about other states to answer that question. I guess I've not heard of that being used. I have seen where standard periods of time are used, like 6 months or 1 month or whatever. But I've not heard of any using that, but if folks are aware of that, feel free to put that in the chat area. How do you test for herbicides or pesticides? Just like all organics, that's a specialized test. That's where really having professionals test can be very handy. And in fact, that's true of methane and any organics. Organics testing is challenging. Stray gases are challenging to test for. That's where you really need a professional, and that's where we don't typically recommend homeowners even try to do the sample. That's where you get somebody from the lab out there. Specialized bottles and containers and handling of those samples. Some of them you have to be very careful with cross-contamination and wearing rubber gloves and even what kind of gloves you use. So that gets into a lot more complicated sampling, and it's more expensive as a result of that. I don't know if I missed any or not, John. Am I missing anything here? How to find a professional? You mean professional water testing lab, well driller? I'm not sure what professional you're looking for, Sherry, and maybe what state you're in would be helpful. Here in Pennsylvania, there are places you can go to find accredited labs. The DEP has a website with all the accredited labs listed, and most states do the same for their accredited labs. If you're looking for a well driller, the National Groundwater Association has a great website called wellowner.org, where you can go on there. There's a little link to find a local contractor, and you can find the list of local NGWA well drillers there. Water well drillers, I should say.
Bryan, thank you very much. And you answered a whole slew of questions and just over our time, which was perfect.